time for example 2, I went ahead and wrote it on the board. F of x equals 10 times 1/2 to the power of x plus 4 minus 1. The parent function would be, and I'm going to label this as p of x, so p of x equals 10 times 1/2 to the power of x. In this example, I am just going to right away start by graphing the new function. What we're going to do is we're going to just take one of the points from the parent function. So 0, 10, we're going to take 0, 10, and then we're going to write about the shift. So the x plus 4 is the horizontal movement. The minus 1 is the vertical movement piece. Again, the vertical is the number that's alone. The horizontal is the piece that's connected to the x value. H is equal to -4. K is equal to -1. And just remember from that first video that our formula says x minus h. So in this case, it'd be x minus, it must be a -4 to yield this +4 result. So we have the minus, we have our h, so that's why h equals -4. And that goes along with our idea that when you see a +4, it's the opposite of what it was. So we would think when we see +4 that it means that we move to the right, but +4 actually means we move to the left because h is really -4. So I'm going to draw an arrow to the left and put a 4. I'm going to put an arrow downwards and put a 1, so we're going to go downwards 1 unit. And then I can take 0, 10 and I can subtract 4 from the x value because that's the horizontal movement. I can subtract 1 from 10 because that's y, it's the vertical movement, and I get -4, +9. So my first point is -4, +9, and I'm going to graph that in blue for my new function. So -4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So -4, 9, I have graphed. Now I'm just going to plug in some random points and try to get out some nice values that'll allow me to quickly graph this. So for x, I'm going to put in, let's put in -3. So if I put in -3, -3 plus 4 is going to give me +1. 1/2 to the power of 1 is just 1/2. 1/2 times 10 is 5. 5 minus 1 is going to give me 4. So if I plug in -3, I get out +4. So -1, 2, 3, +1, 2, 3, 4. And then I can graph that value. And the next thing I'm going to do is I'm going to put in the asymptote. And that's at y equals 0. And that's for the original function. Now I need to think about how it was shifted. So it was shifted, the asymptote was shifted down -1. So in green is my original asymptote. And now I'm going to shift it downwards 1. So the new asymptote will be at y equals -1. So then when I graph this function, I just make sure I'm approaching, getting closer to y equals -1. So I've graphed it. Now commonly they're going to give you two graphs and have you compare one to the other. So let's go ahead and go back and let's just graph the parent function and look at how we could take the parent function points and shift it to get the new function that's drawn in blue. So 0, 10 is one of the points on the parent function. So I'm going to go left to right, 0, up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 10 I just graphed. And then let's plug in a value of 1 for x. So if I plug in 1 here, 1/2 to the power of 1 is 1/2, and half of 10 is 5. So I get 5, so I could graph 1, 1, 2, 3, 4, 5. And then we already in green have the parent function's asymptote, so I'm just going to take those 2 points and then I'm going to approach 0, so you can see the basic shape. And then what I'm going to do is I'm going to take this red pen and start at one of my points that I drew in black, and I'm going to go to the left 4 and down 1. So I go 1, 2, 3, 4, and then down 1, and you'll see I already have a point there. I'm going to take this point now. I'm going to go to the left 1, 2, 3, 4, down 1, and I also had a point there. So just keep in mind that when you have the original and then you create the new, you can literally go to the left and down whatever the values are right here. Translating an exponential function is very much like when you translate a shape, like we did when we looked at the 8th grade math material.